Hi, everyone, and thank you so much for joining us today. We're very excited to host this webinar, and today we're going to have HashiCorp's own Raymond Austin, our Director of Product Marketing, and Kevin Corbin, a Senior Solutions Engineer. So today they're going to provide an overview of the Consul 1.7 release, and they're going to dive deeper into the namespaces features. We will spend the last 15 minutes of the webinar dedicated to a live Q&A. Just so everyone knows, the webinar is being recorded. So usually within a day or two after our team finishes post-processing, we'll make that available to everyone. So I'll email that out to everyone that signed up for the webinar today. And then feel free to put your questions into the Q&A box as we go through the presentation. We're definitely going to wait until the very end to answer them, but it's easier if we see them coming through as the presentation comes over, and then that way we can start aggregating them and make sure that everyone gets their questions answered. So with that, I think we're ready to get started. So off to you, Raymond.
Great. Thanks, Ed. Good morning, everyone, and welcome, or good afternoon, depending on what time zone you're at. So my name is Raymond Austin. As Ed says, I'm from HashiCorp, as well as Kevin Corbin. And so we're here to talk about Consul and how it can simplify self-service governance and operations using namespaces, which is a new feature we recently released as part of the 1.7 update. Before we dive into it, just a little bit about HashiCorp. We provide a common cloud operating model delivered as a set of tools and workflows across several areas. So provisioning with Terraform, security with Vault, networking with Consul, and the runtime of applications with Nomad. And so our focus today will be on around Consul and how namespaces adds value in enabling cloud networking automation. So before we get into the specific topic around namespaces and Consul, I thought it'd be useful to spend just a few minutes summarizing Consul and what are the key drivers resulting in the need for a common cloud operating model, specifically for networking. So you've probably seen a version of this illustration before, where you have enterprises with traditional data center environments with dedicated infrastructure moving to more of a modern data center environment. So you have applications that are born in the cloud, like email and mobile devices. These mobile and email applications may run in a containerized environment, or they even may run in a serverless environment. Oftentimes, they need to connect to other types of applications like database and ERP that in the past have run on bare metal servers and virtual machines and hosted in either a private data center environment or a private cloud environment. You also may have applications that are being spun up. For example, you may have a machine learning initiative and you're spinning up TensorFlow on GCP or Active Directory and Microsoft applications on Azure, or object storage in S3 with AWS, right? And so you need a multi-cloud approach for not only deploying and managing these applications at scale, but also as a way to connect them. So what this means is reimagining the stack across several areas, including provisioning, security, networking, and runtime. And the implications of the cloud operating model for networking means moving away from more of a static IP environment. So where you have, for example, maybe just a very few number of firewall rule configurations, to more of a dynamic IP environment where you have lots of load balancers and firewalls that are connecting applications. You have many firewall rule configurations with really no clear network perimeters. And now you start to have applications that are broken down into more finer grained services. And so this slide illustrates the difference between, let's say, a monolithic application and moving to more of finer grained services. So you have, a web service, a mobile service, an API service. These services are all connecting together to authentication, user, and some of the backend services. And so the benefit here is that teams can now develop, deploy, and scale these applications independently from each other. But it makes the task of managing these services difficult unless there's really a different approach for services networking and security. So what is Consul? So Consul provides a foundation of cloud network automation for services networking based on a guiding principle around a central shared registry. And so there's two things around this shared registry. One is allowing operations teams to decouple IP addresses, spin up services, and register them. And then number two, the concept of identity. And this is around being able to connect service A to service B versus using traditional IPs to connect to each other. Another way to think of it is it's a software-based approach for connecting and securing services across many runtime platform and cloud environments. And so with Consul, we have 3 use cases. The first one is around service discovery and health monitoring. And this is where Consul provides a real-time directory of what services are running, their location, and overall health status. Today, there's a huge pain point around a number of disjointed and manual solutions that do this. So you may be using Kubernetes service discovery, but it only operates with Kubernetes, or you may be using other tools like CMDB and other single cloud tools versus more of a unified approach and a single source of truth for discovering and tracking these services across, across more of a broader cloud environment. The second use case is around network middleware automation, and this is where services can publish their location using Consul, and then devices like load balancers and firewalls can subscribe to service changes, and now services can be scaled up and down or fail gracefully without any operator intervention. And so the main pain point that this use case goes after is the fact that today there are many different more manual and ticket-based approaches to reconfiguring these load balancers and firewalls. And this often stymies applications in terms of their throughput, in terms of how fast they can quickly be developed and rolled out. And then the last use case is around zero trust networking with service mesh. And so this is where things like routing and authorization is done at the application endpoints versus in the middleware itself. And so the main pain point here is that it becomes difficult to scale network topologies, especially over east-west networks where you have a lot of traffic connecting services. And so with service mesh, the topology is much simpler and easier to manage. You remove the need for expensive firewalls. And now you're using service-to-service traffic, which is identity-based and fully encrypted using mutual TLS. And you're creating policies that can be defined using intentions with logical services versus, again, going back to using IP addresses. Consul is one of our most heavily downloaded offerings today, with over 1 million monthly downloads, and it's been used and deployed at scale in a number of different enterprise environments. Okay, so the great thing about Consul is that you can deploy it either on-prem, in the cloud, across regions, across multiple data centers, across many different runtime platforms, so that it truly provides a unified networking solution for services and a single control plane to enable multi-cloud networking. In terms of adoption, we see customers follow this common maturity model that you see here on the right that allows them to realize value immediately as they deploy Consul in the beginning stages, maybe as an open source offering for individuals and practitioners. And they may be using service discovery for that purpose. Later on, deploying Consul in production within an enterprise environment and to do things like automate their network middleware with load balancers and firewalls. And then later to enable zero trust networking using a full service mesh. And so as organizations scale their environment, there are often larger and more broader application teams. And it really becomes necessary to follow DevOps best practices around ensuring continuous delivery across continuous delivery software across dev, test, and production. And so with Consul, managing services is achieved first by deploying the software within a data center environment. And so we call that a cluster, which includes a group of servers and many connected clients or nodes. And so there are several ways to manage clusters today. The first one that's shown here on the slide is to assign a single team per cluster. And so in this scenario, there's really no central operational team ensuring consistency between what team 1 on the left and what team 2 on the right is doing. And this creates more of a shadow IT environment where it's really difficult to maintain consistent policies for things like control and security. The other problem with this approach is that it's often expensive, since for every Consul cluster, you need to have separate number of servers used for HA and clients that run on each node. And so oftentimes you're oversubscribing across multiple clusters. Another way to manage clusters would look something like this, where you share clusters across teams. And so in this scenario, you can overcome shadow IT by enabling more of a central way to manage operations while achieving a higher utilization of resources. So while this may seem to be the right approach, the main issue here is that a security team or an operation team needs to step in and decide, who needs to manage the permissions of who can register what services, and making sure that the teams don't step on each other's toes, right, when accessing resources. Although the teams want to manage their own services with self-service and share the same service name, this approach creates the added challenge of creating things like meta tabs and different service names to ensure there's no conflicts that exist, also leading to a higher risk of misconfiguration. So this is an illustration of what a service name sprawl looks like. So here in this slide, you have Team 1 and Team 2. They're each creating their own distinct names. So you see here Team 1 creating service name Web A, Database A, and API A, while with Team 2 on the right, they're using service names Web B, Database B, and API B, right? So for many customers, managing modular applications can be quite a nightmare with dozens, hundreds, even thousands of services that need to be created, registered, and modified across the many teams. So what is Consul Namespaces? With Namespaces, you can now share a single cluster for organizations who are dealing with the high growth of services across many user and team environments. And so this is achieved by creating isolated management environments in a shared cluster and enabling global operators to delegate the ability to manage policies on a per tenant admin basis. So you see here, you have one shared, on the slide, you have one shared Consul cluster, and you have a global operator that can assign per tenant admins the capability to manage their own policies regarding services. So the benefit of this approach with namespaces is that it allows the reuse of service names across teams. And so this removes the requirement to coordinate resource names between teams. And so here on the diagram in the left, you have with Team 1, Team 2, and Team 3, you have the same service name, Web and API, right? The other benefit of namespaces, as I mentioned, is that you can delegate admin privileges to a given team. And so this is a super admin person that can delegate to individual teams, things like ACLs, policies, tokens, services, and the like. And this, truly enables self-service of these things, on a team basis. Okay, so in terms of where you can get namespaces, it's part of a broader release of features in 1.7. The other feature as part of 1.7 is GCP snapshot storage, which enables point-in-time backups of things like KVs, ACLs, service catalogs, and the like. And then we store the backup file in GCP in addition to other cloud providers like Amazon S3 and Azure. And then the other feature as part of 1.7 is an AWS PCA. And this we've added this as a certificate authority option for Consul, in addition to using Consul native CA with Consul and Vault to manage and sign certificates. So this is great for existing AWS customers that want to leverage a PCA as a certificate authority. So with the 1.7 release and namespaces, we provide organizations a more of a future-proof way to support individuals to large teams. And this is delivered using or through our governance and policy module, which is our newest enterprise module, providing a standard way to create policies around managing services, and over time providing organizations with more finer-grained policy-based decisions, further enabling cloud networking automation for services. In addition, we offer today other enterprise features, for example, additional resiliency with services for your services environment, as well as supporting additional requirements around scalability and performance. So to summarize, Consul provides a single workflow to enable a new software-based approach to networking and security as part of a common cloud operating model. And Namespaces is our latest offering to help simplify self-service governance and operations. And with that, I'll hand it over to Kevin, who will run a demo of Namespaces. Kevin?
Yeah, can you guys hear me okay?
Yes, we can.
All right, let me get set up here with the demo. And are you seeing my screen here?
Yes.
Awesome. So yeah, I think what we'll do for the demo is we're going to just kind of take a double click on some of the pain points that Raymond mentioned about, what this looks like in organizations as they scale out the number of services, both before the namespaces feature and then after. For the demo today, I'm going to be using primarily the CLI and DNS interfaces for Consul, but this feature is present in sort of all of the API and UI components as well as we near the release of the general availability of 1.7. So to get started, we have just a simple cluster here that we have a single member. Now, as in production, we would have 3 or 5 or more of these servers and a number of nodes as well. And that starts to create the challenges as we talk about scaling this across multiple teams and multiple clusters and the number of infrastructure required. We have a single service registered currently. So we have our Consul service being advertised in a service registry. But to get started, let's go ahead and kind of take on the role of a first team that would come in and they say, hey, we've got an API service that we're going to publish into the registry. And so we've registered that API service. And as a result of that, then other teams that have downstream dependencies or upstream dependencies on that API can then discover that service through the DNS interface, which is kind of the least common denominator by the way that we would discover these services in the registry. And you see, sure enough, I have now my IP address where that service happens to be living at this point in time. Now, the complication of this comes in that, in this day and age, every team is developing some sort of an API for their product. And so we have another team that may come along and want to register a service with the same name. And this is where we start to run into the complexities of this, because now we've clashed. And when another group is trying to discover that service, it's sort of like, well, which API are we talking about? And now we may potentially have registered a new API for a new team, but caused an outage for the first team that has their API. And so how we start to think about this, especially when you get into more complex environments where we're taking advantage of some of the load balancing and layer 7 features of this, is that we might have another example of, say a web service that a team is registered and they have multiple instances of that web service. And then, same story as before, that second team comes along and they register their web service as well, potentially running on the same host, but maybe a different port here. And now the ramification is that Consul is going to do its thing and end up actually load balancing these. So when we discover this service now through the DNS interface, what ends up happening is we return the full set of all of the healthy instances of this. And we're effectively now thrashing between 2 different services that happen to share the same name, but are actually providing distinct differing functionality provided by the 2 different teams. And so this is where, as Raymond pointed out, we kind of see 2 common patterns that end up happening in this scenario. The first is that we create a dedicated Consul cluster for each one of these teams so that they have the full namespace at their disposal to register their friendly names and be able to resolve those as mentioned. The second is probably a little bit more cumbersome in that we start to see organizations that say, okay, well let's coordinate the strategy around, okay, team 1 is going to prefix their team name with all of the services that they register, and then team 2 can come along and likewise prefix their API with the team 2. And this has a couple different drawbacks. One is we've got to coordinate tightly this coordination of who's the prefix. The global operator then has to create ACL tokens that match that prefix name. The operators have to then secure their services using those tokens, and really just creates an additional burden on the global operator. And ultimately that's slowing down the delivery of the services team. And that's what we want to try to solve with this namespaces feature. So to take a peek at what namespaces look like, the first thing that we're able to do is actually define a number of namespaces in a simple JSON format or HCL format, if that's your preference, and say, hey, I want to create a kind of a shared service and a dedicated console environment for team one. And then I want to create, actually push that against the console API to create that namespace. And then likewise, team two, we would define a similar namespace for them, and then register that service with console. So now we have kind of our console namespace list here where we can see, okay, I've got my default namespace. So if we do nothing and don't opt into this, we still continue to register sort of against that default shared namespace. But now team one and team two have the ability to have their own, kind of slice of the console cluster, so to speak. And now, as the global operator, the next thing that I can do is actually delegate out the responsibilities of sort of the ACL token creation and being able to administer those policies by generating a token against each one of those namespaces. Now, for clarity in the demo, I'm actually calling out a namespace here as a CLI option. Ultimately, we'll be able to infer the namespace that a token belongs to once that token is presented to us. So we create a token for team one, and now then we can come in and create a second token for team two. And this ultimately then gives them the ability to have full control over their environments. So I'm going to quickly grab this secret ID here, and I'm going to switch kind of personas here. So now I'm the sort of team one administrator, and what I'm able to do is register this token with my CLI, and then ultimately I can now look at things like, well, what is that policy allowing me to do? What do I have access to? So with this token, it says, hey, that you have the ability to, have all privileges within this namespace. I can write ACLs for it. I have a full, the full key prefix available, as well as sessions and service names available to me in that namespace. And now what can end up happening is when I try to, as that operator, let's say I were to try to go back to our previous example where I've got my web service and I want to actually register it, and I'm not specifying, a specific namespace, or the namespace isn't being inferred by the token, we get this permission denied error because we only have control over our tenant namespace and not adjacent namespaces or the default. So I can eliminate those prefixes now and come back to our example where I'm registering, my web service, and I'm registering my API service here. And then from a discovery standpoint, again, we've introduced hierarchy into the DNS interface as well as the API interfaces, such that when somebody wants to actually discover my service, it's available as a subdomain off of the DNS prefix that's being used here. So I'm querying for the web.service provided by team one in data center one in my shared console cluster. And I get the response there for that. Likewise with my API service, I have the ability to query for that and get a resolution that doesn't require the burden to be put back on the the global operator or the shared services group that's providing the console clusters. Now, the next thing that we can do is then we say maybe we want, in a high security environment, we still want to have that granularity where you have kind of the teams within teams effect. And in that environment now, rather than involving the global operator into the scenario again, this namespace administrator would also have the ability to then create ACL policies for a given service. We can take a peek at what that namespace policy that I just registered looks like here. So now I'm saying for this namespace, I want to give the prefix of API or that API service name out to the team within a team that's responsible for that particular microservice component, and then they have full control. So we'll kind of switch gears a little bit here and take a look at what this impacts from team two. And likewise, what we have is we've issued this secret ID for the second team member. They can go in and set their token appropriately. And then likewise run those same service collisions that we demonstrated before, but now when they register them in their namespace, again, same friendly service name, a web component, and an API component of it. But then we'll look at it from the, more of a CLI-centric view from the Consul CLI and say, hey, I want to query all of the services that are available in team 1 as an example, which I don't see anything because I'm using the team 2 token at this point. If I were to actually query for the namespace that I have ownership and privilege into, you can see I have my services registered here, and I'm able to also define those as DNS queries as well, as we demonstrated before. So again, that's kind of the short demo version of what we're talking about here, and hopefully illustrates, some of the complexities prior to the namespace feature, and then what the benefits and how you might start to use the namespaces feature in the 1.7 release. Ultimately the benefits are that we can consolidate infrastructure, share a cluster across multiple teams or teams within teams, while delegating the policy management and ACL token creation process back to those individual teams, that ultimately will result in a faster velocity of the delivery of our services. And with that, Raymond, I think I'll hand it back to you and we'll take some Q&A.
Sure.
It looks like we do have a couple questions starting to come in, Ray. I'll take the first one here.
Sure.
Which is when automating namespace creation, what risks and concerns come up in provisioning? I think in general, like at the time of creation, you kind of have some of the same concerns that you have today about we have to maintain a unique name for the namespace. But then ultimately that's a one-time concern, and then we're delegating the risk out to a particular namespace without having to worry about, is that going to step on toes of another team and things like that. So we're sort of front loading that risk that's pervasive in Consul prior to this feature, allowing it to be that one-time concern. We also have a question about services can be shared across namespaces. The answer there is yes. I mean, similar to how Vault functions, we're ultimately just enabling another level of hierarchy in there. So it is possible for a token to be created that would potentially have access to multiple namespaces. And then those services could in fact be shared across namespaces.
Hey, Kevin, there's a question coming in on the chat panel around, is it possible to have multiple levels of DNS within the namespace name?
Yeah, so if I'm understanding the question, the namespace is included in the DNS name for services. Is it possible to have multiple levels of the DNS label? So today we have the ability to have kind of the two-level hierarchy, which is the namespace and then the data center name. The service names themselves, I mean, I believe because, and I'm not 100% sure on this, but because the DNS specification allows for dots in the name, I do believe that you could have like a service registered called service, web.dev and web.prod, although I'm not sure that that's probably the best use case of sharing a cluster because of the risk of doing so. But yeah, I mean, I do believe you can sort of overload it again there. Another thing that's probably worth pointing out is we do have in my queries that I was showing where I was like team2.dc1, there are some configuration knobs that will allow you to prefer which location of the namespace is. So maybe I don't want to have to specify the data center every time, but instead I can, just prefer that the namespace be that, next to last significant subdomain deal. I hope I answered that question correctly as I understand it.
So we got a question around how many namespaces do you support? And the answer is, I think, pretty much unlimited. So that there is no limit in terms of the number of namespaces that you can create. So there is a question around, is this available, is namespaces available with the enterprise license or included as part of the enterprise subscription? So today with Consul, we provide, of course, there's an open source offering, but then we have packages for enterprise use cases, and we also have modules. And so with namespaces, this is going to be available as part of the governance and policy module, which is a separate enterprise license.
And there was a question on the Helm chart. Will the Consul Helm chart be updated to reflect this new architecture? That, I believe the answer is yes. I've seen some work that's being done in terms of defining requirements and whatnot for to be able to turn this on in a Kubernetes environment where Helm is the kind of preferred mechanism to deploy Consul. Not sure on the timelines of that, but yes, I believe that work is sort of underway.
Yeah, so there's another question around how do we use Consul namespaces with Vault, and Vault uses a similar feature. I don't know, Kevin, if that's a separate, if there's any integration there between the two.
Yeah, I mean, I think foundationally, you can look at, like, if you're drawing a comparison, like if this relates to how Vault namespaces work. Yeah, I mean, I think the idea is to provide the the shared cluster, but then give the consumers of that cluster the illusion that it's kind of theirs, or we call it vaults within vaults, where in that feature in Consul, same thing. You have kind of a Consul cluster within a Consul cluster. We will be, there's one other question in here of providing an example with namespaces using Consul Connect and Consul intentions. That is something that we intend to do. There'll be a learning guide out for that shortly, but we didn't have anything prepared for the service mesh components today. I think just to double click on that a little bit, the idea would be, in addition to being able to delegate the ACL tokens back to that namespace administrator, so too would they be able to manage the intentions within that namespace. And then you kind of have like a double blind scenario where I can, in one namespace, I can create an intention that would allow somebody in another namespace to then ultimately create their side of the intention to get the access that's required in a service mesh use case.
Yeah, there's a question around what's the primary reason for this multi-tenancy. And so if you recall a slide, there are two things. One was to reuse service names, and the other one was more around delegation of self-service across for each team. But just a disclaimer on the multi-tenancy, I would say I would describe it as more of a management isolation and not full fault level type of isolation. So there is no concept of hardware based or full fault level isolation. Just think of it as more of a management level resource isolation between within a namespace.
All right, I think that was the last question. So we're ready to wrap up now. If anything else comes up, though, you will receive an email in a couple of days with the recording of this webinar, and you can feel free to ask us questions over email as well, and we'll be happy to get you to the right resources. I hope everyone enjoyed today's webinar and has a better understanding of Consul 1.7 and specifically more around namespaces. Like I mentioned before, we will be sending out an email follow-up with the recording that will include the Q&A and the slides that were presented today as well. So you will receive those resources in a couple of days. So thanks everyone, and have a great day.
And just a selfless promotion around for additional information on namespaces. There's a lot of information posted on HashiCorp.com, specifically the Learn site has a ton of resources on it. So feel free to peruse at your leisure. Thank you.
Browse, learn as well.
Yeah.
Thank you.